Hello everyone, welcome to the channel Statistical Hub. So in this lecture we are going to discuss percentiles and deciles. Okay, now let's see it. So in the previous lecture we have discussed range and interquartile range. Interquartile range, right? Okay, now these two both give us a way of measuring how values are dispersed into a data set. Okay, the range is the difference between the highest and lowest value, that is upper bound minus lower bound. Okay, and the interquartile range focuses on the middle 50% of the data set of the data. Okay, now the question arises here is, so are they the only measure sorts of ranges we can use to know the dispersion of the data? Okay, now there are other sorts of ranges except these. See this, that when we have applied a range, okay, and because the range are so sensitive to the outliers, we came with the concept of interquartile range. Okay, and these interquartile range are less sensitive to the quartiles to the data set because they use only middle 50% of the data set. Okay, they cut down the rest of the 50% of the data set. We have done this in the previous lectures. They use only 50% of the data set. Now see this, the interquartile range is quite common, but it's not the only way to measure the range. Okay, we can construct mini range. We can construct other mini range like the quartile one. In the quartile, we have divided the data into 4 parts. Okay, and in the interpercentile range, we can see that. So we can split the data into 10 parts too to create our mini range. Okay, and splitting the data into 10 parts is called deciles. Okay, is called deciles, and we can also further construct these mini range if we break up a data set into percentages. The value that split the data are called percentiles. Okay, now let's look at it like this. This is an example set. Okay, now in this you can see that we have splitted the data into 10 equal parts. Okay, this is the same set of data, but it's now split into 10 equally sized parts. Okay, 10 equally sized chunks. Each chunk contained 10% of the data. Okay, now you can see that this chunk contained 10% of the data, this part contained 10% of the data set, and they both contain 20% of the data set. Okay, so we have divided this data set into 10 equal parts. Okay, and we can use these divisions to create a brand new mini range like this, that we have written this down, that if we break up a set of data into percentages, then the values that split the data, the values that split the data are called percentiles. Right? And our data is split into tens, like 10 parts. Then the data is said to be the divided into deciles. Okay, now we can use percentiles to construct a new range which is called the interpercentile range. Interpercentile range. Now let's see this, that what is interpercentile range. Okay, now for that let's just first understand what are percentiles. Okay, now percentiles are values that split your data into percentages, in the same way like quartiles that split our data into quarters. Okay, percentile splits our data into percentage. Okay, now each percentile is referred to by the percentage with which it splits the data. So the like 10th percentile, if we are talking about 10th percentile, then this 10th percentile is the value that is 10% of the way through the data. Through the data. Okay, look at here that if we are talking about k% of the data, that is denoted by pk. If we are talking about k percentage of the data set, then it is denoted like by pk, that is kth percentile. Then this k% of the data set and the value is here, which is depicting 10% of the way to the data. That is pk is the value k% of the way to the data, and this is the remaining data. Okay, now it is like 10th percentile, then 10% of the way to the data, and this is the remaining 90% of the data. Okay, so if this is 10%, then this is the remaining 90% of the data. Okay, now if we talk about the quartiles, then quartiles are actually a type of percentiles. Okay, so what we have in the quartile is upper quartile, middle quartile, that is median, and lower quartile, upper quartile, that is q. This is lower quartile and this is upper quartile, q1 and q3. Okay, now lower quartile is actually p25. Okay, p25, and this is actually middle quartile is actually p50, as it contains 50% of the data set and it contains 25% of the data set. And pq3 is actually p of 75, that is 75% of the data set. Okay, now if you look it into like this, that if we are talking about the lower quartile, then what does this lower quartile depict? This lower quartile is like this. This is 25% of the data set and the remaining data set is this. Okay, and this is the value of the P25, which is the value that 25% of the data way to your data. It is 25% of the data set. Okay, and it is splitted by this value, that is P25. Okay, and this is the remaining portion of the data. Similarly goes for upper quartile. We have some data and this is 75% of the data here. We are considering 75% of the data here and the remaining part is here. Okay, now let's consider an example. What is the Okay, so the example is, suppose you heard you scored like 50 in your statistics test. Okay, 50 in your statistics test. Okay, now with just this number 50, you can't tell that whether you have achieved great marks with relative to the other marks or not, with relative to anyone else. Okay, so but if you are told that 90th percentile 90th percentile for the exam was 50, you know that you scored the same or as better than 90% of the people. Okay, so it is like this is the test score for all the people, and if you scored 50 and knew that 90 percentile for the exam was 50, this is p90 is equals to 50, you would have beaten or matched the score of 90% of the other people. Okay, so you have beaten the score of 90% of the other people. Okay, but if I only tell you that you got only 50 marks in your statistics test, then you don't know that what does it actually mean, whether I have performed better in exams or not. Okay, in comparison to the other students. But this information of the percentiles gave us a rough idea that what does it actually means in relative to the other students. Okay, now let's just see that how we can find the percentiles. Okay, so for finding the percentiles, our very first basic step is to arrange the data into ascending order. Ascending order. The first thing is arrange the data into ascending order, and the second thing is to find the position of the kth percentile. Okay, if it depends on the percentile you are finding, like 20%, 20% is 30 percentage, 50 percentage, whatever type of percentage you want to find, you will have to find that 30th percentile value. Okay, now I want to find the position of this kth percentile. Okay, position of this kth percentile. Okay, now for finding the position of this kth percentile out of n numbers, what is the formula? Calculate k n by 100. Okay, the first thing is calculate k n by 100. If this calculation gives you an integer value, if kn by 100 gives you an integer value, then your percentile is between halfway between the position of kn by 100 value, like kn by 100 value, and the average of the next value. Halfway between the kn by 100 and next positions average. Okay, so it is saying it like this, that if you have like 125 number, if we have n is equals to 125, okay, then if I calculate kn by 100 at this time for the 10th percentile, okay, for the 10th percentile, then what will be the number? That is k is equals to 10. Then 10 125 divided by 100 is equals to 12.5. Okay, now the other thing is, if it is an integer, then we are going to take the average of these corresponding two numbers, that is the integer number and the next number to it, and we'll take a average of it. Okay, and if this is not an integer, if this is not an integer, in that case we are going to round off the values, round off the values, and that position, that round off position uh, is the kth percentile at that time. Okay, so if I take out this one, then it will be at the 13th position. The number at the 13th position is my 10th percentile. Okay, similarly goes for this one. The number that we got after the taking out the average of these two positions data will be the number for the kth percentile. Okay, now if you look at the deciles, how can we find the deciles? So deciles is basically dividing the data into 10 parts, into 10 parts. Okay, so how can we find the deciles? First thing is same, that arrange your data into ascending order, ascending order. Okay, and the second thing is calculate n k by k n by 10. Okay, where k denotes here the like deciles like d1, d2, d3, d4 to d10. That's how we denote the deciles. Okay, and we denote percentile like p10, p27, the percentage you want to find out. Okay, it can be p20 percentage, p of 47 percentage, any type of percentage you want to find out. Okay, you just have to denote the number uh, in the notation. Okay, now similarly the deciles is like dividing the data into 10 equal parts. Okay, so if you want to find the second part, then you will write it like 2n by 10. Okay, this is the deciles. And similarly, if you calculate this and if this gives you an integer, okay, then that integer will give you the position, like the third position, and the position next to it, that is fourth position. Okay, then that take out the average of these two type of data set, and that will be your respective decile. Okay, dk, for here we are taking a general case, so we are denoting it like dk. And if this doesn't give you an integer, then it will, in this case you are going to round up the values, round off the values, and this will give you the value for the deciles. Okay, now that's how we can find the percentiles and deciles that are very easy to calculate. Let's see them by an example. Okay, before that, see this, that what are actually percentile? Revise it, that the kth percentile is the value that k% of the way to your data, it's denoted by pk. Okay, this is k percentage of the data and this is the remaining data. Okay, now there is a very important plot, you have listened about it, that is box and whisker plots, and that lets you visualize the ranges very clearly. Okay, now we have talked a lot about different sorts of ranges, and it would be useful to be able to compare these ranges. Okay, and box and whisker plot helps us very usefully to let us visualize these ranges. Okay, and it can also be said like only box plot, box plot. Okay, so what does box and whisker plot do is, it shows in the diagram the range interquartile range and median of a data set. Okay, now you can see that more than one set of data, okay, in the box plot more than one set of data can be represented in a box plot. Okay, and to create a box plot, what do we do is you first draw a box, okay, against a scale. This is the scale that we have, okay, and this is, let's say, my score, and this is the frequency. And if I want to draw a box plot, what do I do? Okay, we are going to uh, draw the box plot for like lower quartile. Let's just first talk about the lower quartile. Let's just consider that here is my lower quartile value, okay, lower quartile value, and here is my upper quartile value, okay, here is my upper quartile value. Okay, so this is the box that I have here. This is my upper quartile value and this is my lower quartile value, okay, and the median is between somewhere like this. Okay, this is the value for the median, okay, this is the median for the median. Now this box shows you the extent to the interquartile range. Okay, now after that you can see that what is the interquartile range, that is q3 minus q1. So we know that this is the interquartile range here, this one, that is, this is the interquartile range here. Okay, now we have done interquartile range. We got our quartiles q1, q3, we got our median. Okay, now after these three things we are going to draw the whiskers. Okay, now whiskers to the either side of your box to show the lower and upper bound. Let's say my upper bound goes to this extent, okay, and my lower bound goes to this extent. This is my lower bound and this is my upper bound. Okay, now we can see that this corresponding value is my upper bound and this corresponding value is my lower bound, and the lower bound minus upper bound minus lower bound is my range. So this is the corresponding range for this data set, right? So we got that we can see the range, we can see the interquartile range, the range, median of the data set, upper quartile, lower quartile, but in one whisker plot. Okay, now let's try to draw a proper whisker plot for a set of scores. Okay, now let's see, this is the player, okay, and here's the remainder of the data set. This is the scores that he has achieved. Okay, now I want to draw the plot for it. Okay, that is, if I want to find the range for this player, then what will be the range for this player? That is upper bound, that is 30, and lower bound, that is 3. Okay, so 30 minus 3, 27 is the range. Okay, now we have also find out the quartiles for it. Okay, what will be the q3? What will be the q3? We can find the q3, we can find the q1, and then we can find the interquartile range. Okay, and what is the upper bound? Upper bound and the lower bound of data set. Okay, these are the few things that we are going to need for this data set. Okay, now you can see that what is the upper bound? Upper bound is 30, and what is the lower bound? Lower bound is 3. Talking about the in range, we got 27. Now what is q3? Q3 is, we have done the quartiles in the previous lecture and we know that how to calculate the quartiles. Now if I calculate the quartiles for this one, then let's talk about the lower quartile. We have the frequency, that is 1 2 3 4 5 6 7 8 9 10 11. We have total 11 values. Okay, now the quartile, for the lower quartile, we are going to do 11 divided by 4 and this will give us 2.75. As this is not an integer, we are going to round it off. This is 3. So the third position is the value for the lower quartile, that is 1 2 3 6. 6 is my lower quartile. Talking about the upper quartile, the upper quartile will be 3n divided by 4, that is 3 into 11 divided by 4, that is 33 by 4. So we got like 4, it was 32, that is 8.25, and we are going to approximate this value, that is the ninth position is my upper quartile, that is 1 2 3 4 5 6 7 8 9. Okay, so my upper quartile is 11. 11 is my upper quartile, but which one is the median value? Okay, which one is the median value? We have 11. So we can see that n is equals to 11 and n plus 1 divided by 2. 11 plus 1 divided by 2, that is 12. 12 divided by 2, that is the sixth position. I got my median value at the sixth position. That is 1, 2, 3, 4, 5, 6. This one is the sixth position. So this is my Q1. This is my median. And this is my Q3. So I got all the respective values that I need for the for visualizing, for drawing box and whisker plot. What is the interquartile range? The interquartile range is Q3 minus Q1. So we got 11 minus 6, that is 5, right? Okay, now we are going to draw box and whisker plot for this. See this one. We have drawn the box and whisker plot. Okay, so the lower bound for the player, talking about the lower bound, the first one is 3, and it is 3. We have drawn it here. Okay, this is 3, and the upper bound for the player is 30. This is 30. Okay, here. And the lower quartile is what is the lower quartile? The lower quartile is 6 and the upper quartile is 11. Okay, so we are going to draw lower quartile and upper quartile. This is 6 and sorry 6 and this is 11. Okay, so we have drawn lower and upper quartile, and our median is, what is median? Our median is 10. Okay, so we got median with respect to the 10. We have drawn the line with relative to the 10, and this I got is my box plot, box here. Okay, box here. And this, the range between low upper and lower quartile, the difference between these, this is my interquartile range. Okay, now after this we are going to draw whiskers. So these are the corresponding whiskers here. Okay, that is this one and this one, and this is the range here, that is lower bound and upper bound. And what is the range? Upper bound minus lower bound. So that's how we can draw box and whisker plot. Okay, it's very easy to draw. It's not that hard. You just have to calculate the values and draw it on the chart. Okay, so box and whisker plot diagrams are really just a neat way of showing ranges and quartiles. Yeah, they are very neat way of showing ranges and quartiles. So if your data has outliers, you can easily see it by the box and whisker plot. Okay, now see it here in the box plot, that on a box and whisker diagram, the length of your whiskers, this is the length of your whiskers. If the length of the whiskers increases in line with upper and lower bound, then it means that it has outliers. It has outliers. Okay, you can get an idea that how the data is skewed by looking at the whiskers, Okay, now if the data is symmetric, then the diagrammatic representation of the whisker plot would be symmetric too. Okay, so by just seeing the whisker plot, we can see that whether the data has outliers or not. In this data we have outliers, that's why this whisker is quite big than the other one. Okay, now let's look at an example of the box plot, so we can get a clear understanding of the box and whisker plots. Okay, now it says that compare the ranges of their scores. If we had to choose one player from player A and player B, which one would you choose? Okay, now these are the corresponding two players, and this is the corresponding whisker plot for these two players. Now I have to ask that if I have to choose one player from these both, then which one should I choose? Okay, now player A, this is the box plot for player A, and this is the box plot for player B. Now we can see that player A has a relatively small range. This is the range for player A, and player B has like quite big range. It has this much of range. Okay, and his median score is a bit higher than player B's. This is the median for the player A, and this is the median score for player B, and that is like much somewhere higher than the player B. Okay, now player B has a very large range. Player B has a very large range. Sometimes this player scores a lot higher than the player A, but sometimes a lot lower. Okay, so this data is very variable. Sometimes he has scored like very much, and sometimes he didn't perform that well. Okay, now player A plays more consistently. We can see that player A is more consistent than player B and usually scores higher than player B. Now we can compare the medians and interquartile range. So we'd pick player A. Okay, this is the interquartile range here, that is very less, and this is the interquartile range for player B. So we can see that the interquartile range for the player A is less than the interquartile range for the player B. Okay, so we are going to choose player A from this. Okay, because it has less interquartile range than the player B. Okay, so what we have studied till now is this, that percentiles split your data into percentages. They are useful for benchmarking. Okay, like setting the bench, that is 50% of the data is somewhere. Okay, setting the benchmark like 75% of the data. Okay, so they are useful in benchmarking. The kth percentile is k% of the way through your data. It's denoted by pk. Okay, that's how we denote pk, that's how we denote percentile, and d1, d2, d3, that is dk, that's how we denote deciles. Okay, an interpercentile range is like the interquartile range, but this time between two percentiles. Okay, they are actually similar thing. Okay, the quartiles are the have come to through the percentile. You can say that because Q1 is basically P25. Okay. Now, box and whisker diagrams, or you can say box plots, are a useful way of showing ranges and quartiles on a chart. A box shows where the quartiles and interquartile ranges are, and the whiskers give us upper and lower bounds. Okay, so the box, that is this one, it shows where this is my lower quartile, this is my upper quartile, this is my median, and whiskers, that is this part gives us the range of the data set, that is here it is the upper bound, here it is the lower bound. More than one sort of data can be shown on the same chart, so they are useful for comparison. Okay, so they are useful for the comparison because as we have done in the previous example, they have shown two whisker plots in one chart, and we can easily see by that one has that how can we compare two sets of data in just one format of the chart. Okay, now see this one. The coach is saying that the interquartile range looks useful, but what about players who sometimes get really low scores? If a player messes up on a game day, it could cost us the league. I am not sure that the range or the interquartile range tell me which player is really the more consistent. Okay, now the coach doesn't just need to compare the range of the player's score, he needs some way of like more of getting more accurately measuring the spread of the data. Oh, so he can choose the one player that is consistent in their performance, consistent in performance. Okay, now the problem with the range and interquartile range is that they only tell you the difference between the high and low values. Okay, difference between high and low values. Okay, what they don't tell us is how often the players get these high and low scores. Okay, this is the problem here. And scores closer to the center, and that's important to the coach. Okay, the coach needs the man who is like consistent in his performance, so he can rely that player in the team. Okay, the last thing he wants in an erratic player who will play well 1 week. It is like he want to choose the one player who will perform really well in the game. Okay, he will perform really well in the game. It doesn't be like he have performed really well in the one game and he doesn't perform that much in the other game. Okay, it hasn't going to be like this. He wants someone that he can completely rely on. uh, okay, that he can completely rely on. Okay, now what is the other way of choosing, of knowing the different of choosing of knowing the spread of the data, that how we can know the variability in the data. The other thing is of the variance. Here comes the concept of the variance. Okay, now we are going to see the variance in the next lecture, that how we can use it, how we can calculate it. Okay, before it, let's just try to do an example for the deciles and quartiles and percentiles. Okay, so if we have x, that is 0 1 2 3 4 5 6 7 8. Okay, and the frequency is somewhere like let's say 1 9 26 59 72 52 29 7 and 1. Okay, and we want to know the quartiles, that is upper quartile, lower quartile, and let's find out fourth decile. Okay, d4 fourth decile, and I want to find 27th percentile. Okay, these are the values that I want to find out. So let's see then how can we find them out. Okay, so let's just create cumulative frequency. Cumulative frequency, that is 1. Okay, and add 1 to it, that is 10. Add 10 to it, that is 36. Add 36 to it, and that will be 95. Add 95 to 72, we will get 167. We will add 50 to it, and this will be 219. 219. Okay, add 219 to it, to this 29, we will get 248, and we will add 7 to it, this will be 255, and by adding 255 to 1 we get 256. Okay, so we have n that is equals to 256, right? The sum of all these frequencies is 256, and why we have find out the cumulative frequency, you will see that we are going to use it. Okay, now for finding the median, we are going to do n by 2. Let's just do n by 2, that is 256 divided by 2, that is 128. Okay, 128. Now what do we need? We are going to see the cumulative frequency just greater than 128. Okay, now this is 95, this is the one which is just greater than 128, that is 167. And what is the value respective to this? That is 4. 4 is the value corresponding to this cumulative frequency. See, so we got median that is equals to 4. Okay, so that's how we can find the median, quartiles and deciles when you have frequency type of data set. Okay, so when let's just find out the lower quartile, that is q1. For q1 we are going to do n divided by 4. N divided by 4, that is 256 divided by 4. Okay, and that is equals to 64. Now cf, cumulative frequency just greater than 64. What is this? Which one is this? Just greater than 64 is 95 1. Okay, this one. So we got the value corresponding to 95 1. 95 is 3. So we got q1 that is equals to 3. Okay, now let's find out q3. For that we are going to do calculate 3n divided by 4, that is equals to 3 into 256 divided by 4, which is equals to like 3 into 64. Okay, 3 into 64, that is equals to 192. Okay, so we are going to see the values of the cumulative frequency just greater than 192. Just greater than 192 is 290. Okay, and the corresponding value to the 290 is 5. Okay, so we got q3 that is equals to 5. Okay, now let's calculate fourth decile. For calculating fourth decile, we are going to do 4n divided by 10. So that is 4 by 10, and n is 256. That is 25.6 into 4, which is equals to 102.4. So CF just greater than 102.4 is the value for fourth decile. 102.4, 102.4 is the value like 167. 167 is the value that is just greater than 102.4. So the CF I got, so the value I got for the D4 is 4, right? This is my fourth decile. Fourth decile. Okay, now we are going to find P27, that is 27th percentile. For that we are going to calculate 27n by 100, that is equals to 27 by 100 into 256, that is equals to 27 into 2.56, which is equals to, if we are going to multiply this, that will be like somewhere 69.12. Okay, now look at the CF just greater than 69.12, that is 95. Okay, and the value corresponding to this is 3. So we got P27, that is equals to 3. So we can see that the value for the lower quartile and the 27th percentile is same, right? And the value for the median and fourth decile is the same. Okay, now that's how we can find the percentile, decile, and quartiles. Okay, we can also do it in this way. That's it. That is very quite easy. You don't have to arrange them in the ascending order, like everything, like in the same way. Okay. Okay, so let's meet in the another lecture, and in that lecture we are going to discuss about the variance. Okay, thank you.